Okay, so good morning to all. Okay, from that last lecture we have started chapter number 3. Okay, so in that last lecture we have seen surface roughness symbol. Okay, may I write? In that last lecture we have covered the surface roughness symbol. Okay, then in that we have seen uh, basic surface roughness symbol, then main surface roughness symbol, then surface roughness grades, and also we have seen the direction of the leads. Okay, so that much point we have covered in that last lecture. Okay, may I write? Yes.
Yes, sir.
Okay, so just I will take the review point here. Okay, now see, we are having the three basic symbol for the surface roughness. So just I will draw here and you have to tell me the meaning of that. Okay, now see, suppose first it will be like this. Okay, then second it will be, if it is closed up. Okay, and then third it will be like this, if sorry it is straighter, if there is the circle. And please tell me the meaning of that. What is the meaning of this? Yes, what is the meaning of this? What this symbol is
All
indicating?
production methods allowed.
Yes, means here when such type of the symbol is there on your surface, that time I have to understood we have to produce this type, this surface with the help of the any method. Means there is no any restriction for removal of the material, or if you have removed the material again it is allowed, if you have not removed the material again it is allowed. Okay, so if such type of the symbols is there on the any surfaces, that time you have to understood there is no any restriction. Okay, no any restrictions are there. Okay, if such type of the symbols are there on your surface, that time, yes, what is the meaning of this? That time we
Material
have to
should be removed.
understood. Yes, material
Should be removed.
the material should be removed. Okay, if suppose if you have to manufacture this surface, that and if on that surface such type of the symbol is there, that time you have to understood we have to manufacture or we have to produce this symbol. Okay, but during the production of that symbol you have to remember material should be removed. Okay, material should be removed. Okay, and then what is the meaning of this symbol?
Material should not be removed.
Okay, material should not be, material should not be removed. Okay, now see, this is the basic symbols related to the surface roughness. Okay, if such type of the symbols are there on that surface, that time you have to understood we have to manufacture the symbol, or we have to do the production of that symbol, do the production of that surface. Okay, just considering this meaning of that symbol, means if such type of the symbol is there, okay, for you there is no any restriction for making this symbol, this surface you can prepare this surface, okay, with the help of the any method. If you have to remove the material, again there is no problem. If you have not removed the material, again it is not problem. Means okay, all freedom is given to you. Now if such type of the symbol is there, okay, that symbol having the some restriction, means that symbol is indicate that you have to produce the this surface, but during the production of that surface you have to follow this rule, means material should be removed. Okay, the material should be removed, and if such type of the symbols is there on that surface, okay, you have to produce this surface. Okay, but during the surface, which point you have to remember, material should not be removed. Okay, without removing the material you have to produce this surface. Okay, now see, this is the basic symbols and their meanings. Okay, now see, okay, just I will review here what is the meaning of that surface roughness symbol. Like your surface roughness symbol, it will be like this. Okay, it is correct. And see, this is the surface. You can just tell me, and if this portion, yes, this portion I'm going to write here A, and this portion I'm going to write here B. Okay, for this surface C. Okay, then D is here and E is here. Then tell me the meaning of that. What that A is indicate? Yes, that A is
Roughness
indicate
value.
roughness value. Okay, then that B is indicate.
Production method.
Okay, that B is indicate production method. Okay, then that C is indicate
Sampling length.
Sampling length.
good sampling length. What is meant by the sampling length?
Length taking for checking purpose.
Then D for that.
Direction.
Yes,
Direction of lay.
direction of play. Then what is meant by the direction of play? Direction of play. Then what is meant by the direction of play, and what are the different types of the direction of play? Yes, what are the different types of that? Yes.
It shows the pattern of roughness on surface.
Okay. Okay. Then please tell me what are the different types of direction of play? Yes.
Parallel.
Okay. Parallel. Okay. Then what is the symbol for the parallel? Just we have to draw the two line parallel. Then next.
Perpendicular.
Okay. Perpendicular. Then symbol for the perpendicular it will be like this. Then
Crossed.
okay, crossed, and the symbol for that crossed is the X. Then
Multi-directional.
okay, multi directional, and symbol for that multi directional it will be the yes
M.
M. Then
Circular.
okay, circular. Then what is the symbol for the circular?
C.
Yes,
C.
C. Okay, then
Radial.
red. Okay, then the red. Okay, this is the red. Okay, these are the basic direction of the lay, and here okay, here they will write down one of the symbol like this. If such type of the symbol is there, then tell me the meaning of that. If such type of the symbol is there in this place, what you will
Parallel
understood.
pattern.
Okay, if such type of the symbol is there, that time you have to understood the direction of lay, it will be the parallel. Means whatever the roughness, okay, whatever the pattern of that roughness it will be there, the pattern of that roughness it will be the parallel. Okay, if such type of the symbol is there, that time you have to understood the pattern of that roughness it will be the perpendicular. Okay, and if M is there, that time you have to understood the pattern of that roughness it will be the yes multi-directional.
Multi-directional.
Okay, surface roughness value. Okay, what is the biggest surface roughness value according to our chart?
50.
Okay, the 50 micron according to our chart, that 50 micron is the largest roughness value. Okay, and what is the symbol for that? What is the,
N12.
yes, grade. What is the grade for that surface?
N12.
N12, and the grade symbol it will be the wave type. Okay, understood?
Yes, sir.
Okay, so that much part we have covered in that last lecture. Okay, right now we are going to move toward the next point, that is the fit limit and tolerances. Okay, fit limit and tolerances. So I will erase it. Just 1 minute, I will erase that. Okay, now see the next point is fit limit and tolerances. heat limit and tolerances. Okay. What is the pointer? Limit. Okay, limit and tolerances and fits. So that point we have to study. Okay. Then okay, that limit, tolerances and the fits. Okay. Now say suppose this is the one shaft. Okay. Suppose this is the one shaft is there. Suppose this is the one shaft. And okay. And suppose the diameter of that shaft, it will be the 30. Okay, the diameter of that shaft, it will be the 30. Now we have to produce that shaft. Okay, we have to do the production of that shaft. What is the diameter of that shaft? The diameter of that shaft is the 30. Then please tell me, so it is possible to manufacture exact 30 mm diameter shaft? Exact 30. Okay, it is possible. Suppose we have to manufacture, or suppose we want to produce this shaft. Okay, and the diameter of that shaft, it will be the 30. Then tell me, so it is possible to manufacture exact 30 mm shaft, 30 mm diameter shaft. It is possible. Okay, suppose we have to produce 100 shaft, like same shaft. What is the quantity for that shaft? Suppose we have to manufacture here 100 shaft of diameter 30. Diameter 30. Okay, then tell me, okay, every time it is possible, every time for that 100 and 100 shaft, it is possible to produce with that 30 mm diameter. म्हणजे 100च्या 100 shaftची diameter exact 30 होऊ शकते का? Yes. Whether it is possible or not possible? Please tell me. Yes. Yes.
No, sir.
Why? Why it is not possible? Please tell me why it is not possible. Yes, why it is not possible? Okay, due to the some machinery is there. Okay, some due to some fabrications are there, due to some human errors are there. Okay, due to that, it is not possible to manufacture exact size of product, exact size. It is not possible every time. Okay, sometime it will come 30. Okay, out of that 100 shaft, nearly about 20, or we can say the 50 shaft, it having the exact 30. Then sometime, okay, sometime that exact dimension we can produce, but so every time it is not possible to produce that exact 30 mm shaft every time. Means 100च्या 100 shaft तुमचे 100 सॉरी 30 mm diameter असू शकत नाहीत. It is not possible every time. Okay, why it is not possible? Because of the some machine error, because of the some human error, because of the some vibrations, because of the again different errors are there. Due to that, it is not possible to that exact 30. म्हणजे किती होऊ शकेल तुमचा shaft? Suppose it will be 29.999. Okay, it will be the sometime it will be 30.01. Okay, again 30.02. Okay, sometime it will come 29.98. Sometime it will come 29.97. Okay, sometime it will become 30, exact 30. Okay, like this, like this, we can produce the shaft. Okay, it is correct. Why this variation is come? Okay, why these variations are come? These variations are come due to the some errors. Okay, so Every time it is not possible to produce the exact size product, exact size. Okay, take the example. So I will take another example here. Suppose we have to produce one hole here. Suppose we have to produce one like this. Okay, and so the diameter of that hole, it will be the diameter of that hole, it will be the 20. Okay, so and okay, the same hole we have to produce on the plate, and the quantity of that hole, it will be the this hole आपल्याला एका plate वरचे हे करून घ्यायचे. So the diameter of that each hole, the diameter of that each hole, it will not be come exact. Okay, sometime it will come 30, sorry, sometime it will come 20, sometime it will come 21, sometime it will come 90.99, like this variation will be occur. Okay, why these variations are occur? Due to some errors. Okay, so that if suppose this is the shaft. Okay, suppose we can say suppose A and B is there. Okay, that A, it will be the client. We can say that it is the client and it is the manufacturer. The B is the manufacturer. Okay, that the A person has given order to that manufacturer like this: prepare the shaft, prepare the 100 shaft. Okay, prepare the how many shaft? Yes, prepare that A person has given order to the B person. That B person is nothing but it is the manufacturer, and the A person has given order to the B. What is the order? Prepare the 100 shaft. How many shaft? Yes, yes,
100.
100 shaft. Prepare the 100 shaft, and the size of that shaft. Okay, the size of that shaft, or we can see here the diameter of that shaft, it will be the 20, exact 20, exact 20. That A person has required 100 shaft of a diameter 20 mm, and he has required exact 20 mm. And this A person has given to the B person, and that B person is the manufacturer. Now please tell me that B person has started manufacturing this shaft. Okay, the B person has started to manufacture this shaft of 20 mm diameter. Suppose they have prepared shaft like this. Suppose they have prepared the shaft like this. Okay, this is the one. I'm going to write down here. This is the second. Okay, now see, this is the third. Okay, okay, it is the fourth. Okay, then it will be the 5. Okay, such type of the shafts that B person has manufactured. Suppose they have checked their dimensions. Okay, the diameter of that shaft, it will be the 20, exact 20. Okay, again, suppose the diameter of that shaft, it will be the 90, like this, 19.99. Again, the diameter of that shaft, it will be the 20.101. Again, suppose the diameter of that shaft, it will be the 20.05, like this. Okay, and again, suppose the diameter of that shaft, it will be the 90. Okay, if such type of the shaft they have manufactured. Now, what is the order? What is the order from the A person? Prepare the shaft of exact 20 mm diameter. Okay, And what is the 20 out of that? Suppose that B person has produced the 5 shaft here, for example, 5 shaft. Out of that 5, only one shaft has get exact 20 size. Okay. Then what about that remaining shaft? Whether that remaining shaft it will be acceptable or rejectable. Yes. Yes. What about that remaining shaft? मला सांगा हा ए पर्सन कुठला शाफ्ट ह्यात लागेल? Yes. Yes. Hello.
First shaft.
That a person it will select only this shaft. Whether that second shaft he is accept? No, because its size is vary. Again, it is not exact. Again, it is not exact. Again, it is not exact because their size is not exact. Okay, because that a person has required exact 20 mm diameter of shaft, and that B person has produced only one shaft whose diameter is exactly 20 mm, and remaining shafts are having their dimensions are varying. Okay, so that a person has rejected number of shaft. Okay, that a person has rejected number of shaft. Okay, now see here again. आता मला सांगा, जर ह्या बी न जर एवढे शाफ्ट मॅन्युफॅक्चरिंग केले, त्यातले 100 पैकी समजा जर 50-80 रिजेक्ट झाले आणि 20 जर सिलेक्ट झाले, तर हे परवडणार आहे का बीला? येस, परवडणार आहे का?
नाही.
Okay, for this purpose, okay, for this purpose we are giving, okay, for this purpose we are giving some two permissible allowable values, okay, two extreme permissible values. Okay, to for this purpose or for this problem we are giving two, we are giving the two extreme, we are giving the two extreme permissible sizes. We are giving the two extreme permissible value, or we can say the two extreme permissible sizes to overcome this problem. Okay, to overcome this problem, we are adding or we are giving the two extreme permissible sizes. Two extreme permissible sizes. म्हणजे आता मी काय केलं या ठिकाणी, suppose that a person, just a moment. Suppose this is the shaft, and suppose right now that a person has given the dimension like this. This is the shaft is here. Okay, now see here. Right now the dimension of that shaft it will be like this. Suppose 20. Okay, 20. But that exact 20 is not possible every time to produce. Okay, so that this a person has given two extreme permissible sizes. Okay, that a person has given the two extreme permissible sizes to this size. म्हणजे काय केलं त्यांनी? ओके, म्हणजे काय केलं बघा, फॉर एक्झाम्पल प्लस 0 point plus 0 point suppose 2 and minus 0.2. Okay, if such type of the variation, allowable variation, suppose they have given, okay, such type of the variation they have given. Okay, then what is meant by that plus 0.2 and minus 0.2? Means they have given two limits. Okay, these are called as the limits. Okay, that plus 0.2 and minus 0.2. Okay, these are allowable sizes. Okay, these are the allowable sizes. म्हणजे हे दोन त्यांनी लिमिट दिलं. Okay, then what is meaning of that limit? What is the limit, meaning of that limit? Just here. Okay, how that limits they have given? Limits is nothing but it is the two permissible allowable sizes, two extreme permissible value, we can say. Two extreme permissible value. म्हणजे मला सांगा, what is the meaning of this? That 20 and they have given the limit, that is the 0 point plus 0.2 and minus 0.2. Then how to write this figure? Okay, how that 20 it will become? Right now that 20 it will become like this. Okay, 20 plus 0.2 is equal to and here again that 20 here again that 20 minus 0. Then tell me the answer. What is the answer for that? 20 plus 0.2. What is this?
20.2.
20.
20.2.
20.2. It is correct? Yes.
Yes, sir.
20.2. And what is this?
19.8.
19.8.
8.
Okay. So, yes, what is the meaning of this? What is the meaning of this? If right now that a person has given this limit, okay, that a person has given this limit means that a person, he will told to that b person, okay, see here, that a person, he will be told to that b person, make the or prepare the shaft, okay, of the 20 mm, and but if you are not able to produce that exact 20 mm, then okay, maximum त्याला परमिशन किती दिली आपल्याला? Yes, मॅक्झिमम तुझं जर व्हॅरिएशन झालं, मॅक्झिमम जर तुमचं व्हॅरिएशन ह्या साइज मध्ये झालं तर ते कितीपर्यंत गेलं पाहिजे? मॅक्झिमम व्हॅरिएशन कितीपर्यंत गेलं पाहिजे? 20.2 एवढं जर तुमच्या शाफ्टचा डायमीटर आला, आय विल ऍक्सेप्टेबल. अगेन मिनिमम कितीपर्यंत यायला पाहिजे?
19.8.
ओके, 19.8. ओके, जर हे मिनिमम पर्यंत आला तरीही शाफ्ट it will be acceptable. Means that a person has given two limits, and according to that he has told to that b person prepare the shaft. Okay, then this is called as the limit. That limit is nothing but, right here, that limit is nothing but it is the two extreme permissible sizes. Okay, so I will take another example here. You have to understood what is meant by the limit. Limit is nothing but two extreme permissible sizes. Okay, for example, suppose we have to produce the shaft of diameter 30. Okay, suppose we have to produce the shaft of diameter 30. We are knowing that to produce the exact 30 mm shaft, it is possible to produce. Please tell me faster. To produce that exact 30 mm shaft, it is possible?
No, sir.
It is not possible. To produce the exact 30 mm shaft, it is not possible. So that we have to give the limits. Okay, we have to give the limits like this: 30 plus 0.10 minus 0.10. And how it will become? Okay, then 30 plus 0.10 mm and yes, 30 minus 0.10 mm. Then tell me the answer. What is this answer? It will be the 30 plus
30.1.
30.1 mm, and again here, yes,
29.90.
okay. Now see here, up to that much variation they have allowed. म्हणजे जर तुमचा शाफ्ट किती झाला, समजा तुमचा शाफ्ट असा प्रोड्यूस झाला, सपोज यू हॅव प्रोड्यूस द शाफ्ट लाईक दिस 30.5, it is acceptable, it is acceptable because they have given that much limit. Maximum, this is called as the maximum limit, or we can call it the upper limit, and this is called as the lower limit. It is called as the lower limit. म्हणजे मॅक्झिमम तुमची साईज कितीपर्यंत व्हॅरी होऊ शकते, 30.1 mm अप टू दिस. जर मॅक्झिमम इथपर्यंत गेली इट इज अलाउएबल, आणि मिनिमम इथपर्यंत आली इट इज अलाउएबल. ह्याच्यामध्ये कुठलाही तुम्ही साईज येऊ द्या. Okay, in between that any size is there, again it is acceptable. Then please tell me, if you have manufactured the shaft of 30.5 mm, it is acceptable?
No, sir. No.
Okay, then tell me, if suppose you have manufactured the shaft like this 13.95, it is acceptable? It is acceptable?
Yes, sir.
It is acceptable because it is lies between this limit. It is lies between these limits. Okay, if suppose if you have manufactured the shaft of 19.98, it is acceptable?
Yes.
It is. Why it is acceptable? Yes,
Because that value lies between two extreme limits.
it is acceptable. So for your better understanding, I will take another example. Okay, suppose we have to manufacture the shaft of, we can say the 28. Okay, but that exact 20 mm shaft, to produce the exact 20 mm shaft, it is not possible. So that we are giving the limit. Okay, that big limit for the better understanding I will give here, not in point. Okay, suppose generally we are giving the limit 5 mm. Okay, and minus again 3 mm. Okay, then please tell me what is meant by the upper limit. What is the upper limit? Upper
25.
limit, it will become, yes,
25.
25 mm. Okay, and what is the lower limit?
17.
What is the lower limit? Yes, 17. Now so these are the two limits we are giving. These are the two limits, means the whatever maximum limit is there, it is called as the upper limit, and whatever minimum limit is there, minimum size is there, it is called as the lower limit. Okay, upper limit is nothing but it is the maximum permissible size, and it is the minimum permissible size. तुम्हाला सांगा. Okay, maximum आपल्याला किती दिले? This is called as the 25 mm, 25 mm, and minimum, yes, 70 mm. आता मला सांगा, when you have manufactured the any shaft in between these sizes, in between that two extreme permissible sizes, again it is acceptable. Understood? If you have manufactured the shaft of, 18 mm, it is acceptable? Yes, it is acceptable.
Yes, sir.
Why it is acceptable? Yes, why it is acceptable? Because they have given range ना. म्हणजे आपण आता ए वाला पर्सन काय म्हणतोय बीला, ह्या रेंज मध्ये कुठलाही शाफ्ट बनवा मला चालतोय. 25 मॅक्झिमम शाफ्टची साईज किती गेली पाहिजे, 25 गेली पाहिजे, आणि मिनिमम किती राहिली पाहिजे शाफ्टची साईज, 17 mm राहिली पाहिजे. ह्याच्यामध्ये जर तुम्ही शाफ्ट बनवला, यू हॅव प्रिपेअर द शाफ्ट इन बिटवीन दिस, अगेन इट इज एक्सेप्टेबल. मी तेवढा सहन करू शकतो. इट इज कॉल्ड एज द लिमिट्स. ओके, आता मला सांगा, इफ that B person has prepared the shaft of 16 mm, then tell me whether that A person it will be accepted?
No.
Why it is not? Because It is it is beyond that limit, na? It is beyond that limit. Then tell me, if we have manufactured that B person has manufactured the shaft of 20 mm, then it is acceptable.
Yes.
Remaining student, no one are giving the answer. Remaining student, yes. Remaining students, remaining student, please give the answer. No one are giving the answer. Remaining, at least anyone, please tell me, if you have manufactured the shaft of 21 mm, whether it is acceptable or rejectable.
Acceptable.
Acceptable.
Why it is acceptable, please tell me.
Because in between 17 and 25.
What are that 17 and 25 mm?
Lower limit and upper limit.
Okay, good. It is the 70 mm is nothing but it is the lower limit, means minimum permissible size, and that 25 is nothing but it is the maximum limit, means it is the maximum permissible limit. Permissible permission आहे तुम्हाला इथपर्यंत आणि minimum इथपर्यंत permission आहे. It is called as the upper limit and the lower limit. Okay, understood? What is meant by the upper limit and lower limit? The upper limit and lower limit is nothing but, okay, the upper limit is nothing but the maximum permissible size. Upper limit is nothing but it is the maximum permissible size, and lower limit is nothing but it is the minimum permissible size, minimum extreme permissible size. जास्तीत जास्त आणि कमीत कमी इथपर्यंत चालतात. Okay, so understood? Yes.
Yes, sir.
Now please tell me. I will take another example here. Yep. 15 mm. Okay. And suppose they have given like this 15 mm. Okay. Plus 2 minus 1. Then please tell me what is the upper limit? Yes.
52.
The upper limit is nothing but it is the 50 plus 2. Okay, then how it is? 52 mm. Okay, and what is meant by the lower limit? Yes, what is meant by the lower limit? Lower limit is nothing but minimum permissible size. See, this is the maximum permissible size and it minimum. Then tell me how it is calculated.
49.
50 minus 1. How it is? It is
49.
40 mm. Okay, it is correct. Understood? It is called as the upper limit, means it is the maximum permissible size, maximum extreme permissible size, and it is the minimum permissible size. Then what is meant by the tolerance? Okay, what is meant by the tolerance? Okay, so just here the tolerance is nothing but it is the difference between upper limit and lower limit. Okay, it is the difference between upper limit and the lower limit. Okay, I'm going to write here the tolerance is nothing but it is the difference between upper limit minus lower limit. Then tell me what is the tolerance for this 50? What is the value of upper limit?
3.
Huh? What is the value of upper limit?
52.
52. And what is the value for lower limit?
49.
40. Then tell me what is the tolerance?
3.
Yes?
3.
3 mm. Okay, means up to 3 mm we have to make the variation. Okay, म्हणजे आपल्याला suppose we have to manufacture or suppose we have to produce this shaft of 15 mm. म्हणजे जर आपल्याला हा शाफ्ट जर मॅन्युफॅक्चरिंग करायचं असेल, प्रोड्यूस करायचं असेल, तर आपण किती mm व्हॅरिएशन घेऊ शकतो? 3 mm व्हॅरिएशन जर आलं, प्लस मायनस 3 म्हणजे प्लस मायनस जर एवढं असं व्हॅरिएशन आलं 3 mm, we can call it is accepted. This is called as the tolerance. Understood? Yes.
Yes, sir.
Okay. Now see here again. We have to see here the basic things. Okay. Basic things. What is meant by the what is meant by the nominal size? What is meant by the nominal size, and what is meant by the basic size? Basic size again, and what is meant by the actual size? What is meant by the actual size? Okay, that point we have to study. First is the nominal size, the basic size, and actual size. See, just I will write here the definition. Okay. Okay. So first I will write here nominal size. Nominal size. Okay, now see here, the nominal size is nothing but it is the size of part in drawing only. It is the size of part. It is the size of part in drawing only. In the drawing only. In the drawing only. Now see here, the second size is nothing but it is the, yes, what is the name of second size?
Basic size.
Okay, basic size. I will write here the definition. Okay, then I will explain the concept. Okay, you can also write down. Okay, the basic size. The basic size is nothing but the size of part after giving the tolerance. Okay, the size of part, the size of parts after giving tolerance, after giving the tolerance. Okay, it is called as the basic size. Okay, and the third is what is the third? Yes,
Actual size.
third is actual size. Third size is the actual size. Actual size. The actual size is nothing but size of parts after production. Size of part after production. After okay, these sizes are very important. First is the nominal size, the size of part in the drawing only. Okay, just you have to understand their definition. Then basic size is nothing but the size of part when we are adding limit or tolerance. Okay, then it will become the basic size. And after the production, whatever size are there, it is called as the actual size. Means what? Means what? Suppose, okay, suppose here, suppose, try to understand the concept here. Suppose this is the one chapter we have to. Okay. Suppose you have to try to understand this is the shaft we have to manufacture. Okay, so you don't consider this part. Okay, now see this is the shaft we have to manufacture. Okay, and in that drawing only, if in this drawing we have to show the dimension like this. Okay, it is the 30 mm. Sorry, the diameter of the shaft it will be the 30 mm. Okay. Okay, whatever size we are showing in the drawing, whatever size we are showing in the drawing, that size is called as the nominal size. Understood? Understood? The nominal size is nothing but whatever size we are just showing in the drawing only. Okay, in that drawing only, it is called as a nominal size. Okay, nominal size is nothing but it is the size, which size or which dimension we are showing in the drawing only. Okay, now see this is the shaft, and suppose the diameter of that shaft we are showing here in the drawing itself, it is the 20 mm. That 20 mm it will be the nominal size, because just we are showing in the drawing only. If we are adding, if we are adding the tolerance to that nominal size, okay, if this size we are adding the tolerance, means what? Suppose plus plus 2 minus 1. Okay, then this 20 is called as the basic size. Okay, if we are adding the tolerance to that size, okay, if we are adding the tolerance to this size, it is called as the basic size. It is called as the basic size. Okay, it is called as the basic size. Then you have to add the tolerance. What is the upper limit? Yes, what is the upper limit here?
22.
20 plus maximum permission size is 2. Okay, so that upper limit it will become 20 mm. Okay, and then what is the lower limit? That lower limit is nothing but it is the 20 minus 1. It will be the, yes, 19. Okay, now see that much variation is allowed. Means again here, what is meant by the tolerance? Yes, calculate the tolerance for this. What is the tolerance? Yes, what is the tolerance for this?
22 minus 19.
Okay, upper limit, what is the upper limit? 22 minus 19. Upper limit minus lower limit, it is called as the tolerance. What is the tolerance? 3.
3.
3. Okay, that much variation it will allow. Now see here, after the manufacturing, okay, suppose, say this pen we have to manufacture. Suppose this is the shaft. Okay, this shaft we have to manufacture, and they have given this dimension. Okay, to manufacture this shaft, suppose they have given this dimension. Okay, 20 minus 1 plus 2. Then what is meant by the 20? That 20 is nominal size or basic size?
Basic.
The 20 is basic size because here on that 20 we have added the tolerances. Okay, now 20 is become the basic size. Now okay, हे आपण आता काय केलेलं आहे, अशा पद्धतीने सांगितलेलं आहे असं बनवा. म्हणजे मॅक्झिमम कितीपर्यंत गेला तर तुमचा शाफ्ट ऍक्सेप्टेबल असणार आहे. 22 चा मॅन्युफॅक्चरिंग झाला तर ऍक्सेप्टेबल आहे. 19 चा मॅन्युफॅक्चर झाला अगेन इट इज ऍक्सेप्टेबल आहे, लाईक दिस. Okay, now see they have given the limits like this. The maximum limit it will be the 22 and minimum limit it will be the 9. Okay, and in between that if there is a variation it is acceptable. Okay, it is acceptable. Then what is the basic size? Basic size is nothing but it is the 20 mm. Okay, 20 mm is the basic size. Okay, जर 20 च्या वर 22 पर्यंत गेलं अगेन इट इज ऍक्सेप्टेबल. 20 च्या खाली 19 पर्यंत आलं अगेन इट इज ऍक्सेप्टेबल. बरोबर आहे का? येस. ओके, बट आफ्टर द मॅन्युफॅक्चरिंग, आता हे आपलं theoretical झालं. आफ्टर द मॅन्युफॅक्चरिंग, इफ आफ्टर द मॅन्युफॅक्चरिंग, इफ द साइज ऑफ दॅट shaft it will be the 20 mm. ओके, ह्यानुसार आपण साइज नुसार shaft मॅन्युफॅक्चरिंग केला. आफ्टर दॅट वी हॅव मेजर द साइज ऑफ दॅट shaft and right now after the manufacturing we have measured the size of that shaft and the size of that shaft it will be the 20 mm. Then what is this size? What is this size? Actual. After manufacturing, what is the size of that component? After the manufacturing, म्हणजे आफ्टर मॅन्युफॅक्चरिंग केल्यानंतर मला किती शाफ्टची साइज मिळालेली आहे? 20 mm, 21 mm for example. It is called as the actual size. It is called as the actual size. Okay, so understood that three sizes. The nominal size is nothing but the size of the part, whatever size we are showing just in the drawing only. It is called as the nominal size. When we are adding the tolerances, when we are adding the limit, or when we are adding the tolerance to that value, again that value it will become the basic size. Okay, it will become the basic size. And after the manufacturing, after the production, whatever size we have measured to that component and whatever size it will be there after the production and after the measurement, that size is called as the actual size. Understood what is meant by the nominal size, what is meant by the basic size, and what is meant by the actual size? Yes.
Yes, sir.
So I will take here one example. You have to tell me. That limit and tolerance always given in pointer, but for your better understanding, just I will take the 1 mm. Now see, this is the shaft. Okay, mm. Then then 30 plus, suppose I'm going to write down here 3, and the minus it will be the, and it will be the 31. Okay. Then tell me now, serious, just try to understand this example. Suppose we have to manufacture this chapter. Okay, this is the drawing of that chapter, and in that drawing the size they have shown, that is the 30 mm. Again we have added the tolerance, or we can say the limit to that size, and after that manufacturing we have got exact size of that shaft, it will be the 30 mm. Then tell me what is the nominal sizes here? Yes,
30.
the nominal size is equal to 13 mm. Then what is the basic size? What is the basic size? Yes, what is the basic size? This is the basic size. Now again 30 is the basic size. We have added again 30, it is also basic size we can call. And after the manufacturing, we have got the size, it is called as the actual. Okay, 30. Okay, so understood? You have to remember, ड्रॉइंग मध्ये जी काय दाखवलंय ती नॉमिनल साइज झाली. जर त्याच्यावर मी लिमिट फिट टॉलरन्स ऍड केला, अगेन इट इज कॉल्ड एज द yes, which size? Yes, basic size. After the manufacturing, whatever actual size we are observing, that size is called as the actual size. Okay, now see, these are the basic sizes. Okay, so understood? Yes.
Yes, sir.
Yes. Okay, so I will take here one example. Zero zero, and we are giving the tolerance zone. Suppose that 25.00 plus 0.02 mm and minus 0.01. Okay, then tell me what is the basic size here?
25.
What is the basic size? It is the
25.
25 mm. Then tell me upper limit. What is meant by the upper limit?
25.02.
Yes. Just a minute. Upper limit is equal to 25 plus 0.02. It will 25.02. Okay, it is correct.
Yes, sir.
Okay, then what is the lower limit? What is the lower limit? The lower limit is equal to 25 minus 0.01 mm. Then what is the lower limit? 24.99.
24.99.
Okay. Yeah. Then please tell me the tolerance. What is meant by the tolerance? The tolerance. Yes, tolerance is nothing but it is the algebraic difference between. Yes, tolerance is nothing but it is the
Upper limit and lower limit.
good. It is the difference between upper limit minus lower limit. Then write down the upper limit is 25. Yes,
0.02.
25.02 minus 24.99. Then tell me the tolerance.
0.03.
Yes, 0.03. Okay, now, okay, now see here, I will write down here just okay. Now it is visible.
Yes, sir.
Okay, now see here, for example, just I'm going to write down here. See, this is the hole. See, this is the hole, and see, now see here. So this is called as the tolerance. See, this is the upper limit. See, this is the upper limit for this chapter, and see, this is the lower limit for this chapter. This is the lower limit of chapter. Okay, and whatever difference between that, this is called as the tolerance. See, this is called as the tolerance. See, this is the upper limit, sorry, lower limit. Again, it is called as the upper limit, and this is called as the tolerance zone. This is called as the tolerance zone. Again, see here. See here. This is the shaft. Okay, this is the shaft. This is the upper limit. This is the lower limit, and this is the tolerance. This is the tolerance. Just you have to imagine. Okay, so we will try to present here also. Now say how to draw this figure here. How to draw this figure here. Yes. See, this is the upper limit. This is the lower limit. Now see. If suppose this is the shaft. Suppose this is the shaft is there. Okay. Now see, this is the shaft. What is the basic size for this chapter? What is the basic size?
25.
Okay, now so basic size means we can say the exact size, exact. See, this is the basic size. But it is possible every time, no. We are giving the limits. We are giving the limits. What is the upper limit? Upper limit is the 25.02. Here is 25.02. Whether it is upper or below, this is the exact. This is called as the basic line. Basic म्हणजे exact 25 आलेलं आहे 25. आता ह्याच्यावरती असेल का खाली असेल?
वरती.
Now see, if the size of shaft, it will be like this. It will be like this. म्हणजे जर आपण मॅक्झिमम शाफ्ट जर प्रिपेअर केला, मॅक्झिमम साईज किती असायला पाहिजे शाफ्टची? इट विल बी द 25.02. व्हॉट इज द मिनिमम? मिनिमम साईज किती यायला पाहिजे? इट विल बी द, आता मिनिमम कुठे येणार? ह्या बेसिक लाईनच्या खाली येणार का वरती जाणार?
खाली.
ओके, नाव if what is the size of this lower limit? So this is the upper limit, lower limit. What is the size? Yes. Okay, now see, you just image, huh? Okay, and now see, म्हणजे जर आपला शाफ्ट बरोबर एक्झॅक्ट 25 mm ला मॅन्युफॅक्चरिंग झाला तर इट इज कॉल्ड ॲज द, म्हणजे बरोबर बेसिक साईज ला मॅन्युफॅक्चरिंग झाला. ओके, जर शाफ्ट 25 ला झाला तर इट इज द अप्पर लिमिट आणि इट इज द लोअर लिमिट. सेम म्हणजे जर ह्याच्यामध्ये जर आपला कुठला शाफ्ट मॅन्युफॅक्चर झाला ह्याच्यामध्ये, इट इज ऍक्सेप्टेबल और रिजेक्टेबल?
Acceptable.
Acceptable. Okay, and see, this is called as the tolerance. This is called as the tolerance. Now see, this is called as the tolerance. This is called as the tolerance. Now see here, I'm going to write here. See, this is the, yes, what is this? This is the
Lower limit.
lower limit, and this is the
Upper limit.
this is the upper limit. Okay, so this is the basic size.
Basic size.
Basic size. Okay, now see, understood how it is looking graphically representation of that limit? Yes.
Yes, sir.
Now understood the limit. What is meant by limit? Limit is nothing but it is the two. Limit is nothing but it is the two extreme permissible sizes. Two extreme permissible sizes. Okay. One size is given to the upper side, another size is given to the lower side. Okay, and the difference between that two sizes is called as the tolerance. म्हणजे आपण त्या मॅन्युफॅक्चरला काय सांगतोय आपण? तुझ्या मॅन्युफॅक्चरिंग मध्ये 0.03 जर व्हेरिएशन आलं तर आपल्याला ऍक्सेप्टेबल आहे. ओके, इफ दिस व्हेरिएशन इज एक्सेल 0.05, whether it is acceptable? Whether it is acceptable?
No, sir.
It is rejected. Now see, it is called as the upper limit, lower limit, and tolerance. Okay, now see here. Now see, again there is another pointer, deviation. Deviation. Okay, what is meant by the deviation? What is meant by the deviation? What is meant by the deviation? The next terminology is deviation. Okay, deviation. The deviation, I'm going to write down here the definition. The deviation is nothing but it is the difference between it is the difference between actual size. It is the difference between actual size and basic size. It is the, please write down this definition. It is the difference between actual size and basic size. It is called as the deviation. It is called as the deviation. Okay, actual size. So I will write here once again formula. The deviation D is called as the, it is the difference between actual size. What is meant by the actual size? What is meant by the actual size? Yes, what is meant by the actual size? Minus basic size. Yes, please tell me what is meant by the actual size and basic size.
Size after production is actual size.
Actual
And,
size is nothing but after the production. Okay, after the production. After the production, and here basic size means when we are adding the tolerance. Okay. Okay. It is called as the deviation. For example, the remaining student, please give me reply. What is meant by the actual size? Yes. Remaining.
Size of part after production.
Okay. After the production, whatever size you are measuring, that size is called as the actual size. And what is meant by the basic size? Yes, remaining. Only student, they have given the answer only. Please, remaining. Yes.
Size of part after giving tolerance.
So, and you have to remember the definition. Deviation is nothing but it is the algebraic difference between actual size and the basic size. Okay, so I will take one example here. Okay. For example, 30. Okay. Plus 1 minus 1. Okay. Now tell me what is the basic size is here?
30.
Basic size is nothing but it is the 30. Means that is exact size we can. Okay. Then after the production, okay, after the production, we have got the size. It is called as the actual size. It is called as the actual size. After the production, please write down here their limits. What is the upper limit? Upper limit is nothing but it is the 31. Na? And what is the lower limit? It is the 20. You have to remember. Okay. And what is the tolerance? The tolerance is the 2.
Oh.
Now see here, the actual size after the manufacturing. Suppose the size of that shaft it will be like what we can say 20. Okay, 20 actual size. Okay, it is acceptable, na? It is lies between these two limits. Okay, then how to calculate the deviation? How to calculate the deviation? Yes, deviation is called deviation is equal to, yes,
29 minus 30.
first upon tell me the formula. The deviation is the difference between actual size minus basic size. Actual and basic. Okay, I have written there short. What is the actual size? It is the 29. And what is the basic size? It is the 39. Then what is the deviation? What is the deviation?
Minus 1.
Yes, minus 1. Then minus 1 in deviation. How to show that minus 1 in deviation in graphical representation? Okay, just I will take another example also. Okay, now see, this is the first we can see. This is the first, so that we will understood first. Okay, take another example here. Okay, if the basic size, if the basic size is 30 mm, and if the actual size after the production, suppose actual size it will become 31 mm, then what is the deviation? Then deviation is equal to actual minus basic size. Okay. Then what is the actual? It is the 31. And what is the basic? It is the 30. Then tell me what is the deviation?
1.
1 mm. Means what is meant by the deviation? Yes, whether you have understood what is meant by the deviation? What we can prepare the definition for the deviation? Yes. 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 Please prepare the definition for deviation. For example, suppose, okay, just you have to understand the derivation. It is the algebraic difference between actual and basic size. Okay, so I will explain here the another point, and then I will explain that all thinking graphically manner. Okay, now see here the next point is the zero line. Zero line. Okay, see here the zero line. What is meant by the zero line? These are the very important terms are there. Okay, zero line. The zero line is nothing but it is the graphical representation of basic line. Okay, I'm going to write down here. It is the graphical. It is the graphical representation of. It is the graphical representation of basic size. It is called as the zero line. Suppose that zero line, it will show the exact basic line. Exact basic line. Once again, I will repeat here. It is the graphical representation of the basic size, and you have to remember that zero line, it will show the exact basic size. It will show the exact basic size. Okay, so I will just write down here. Suppose this is the one line. This is the one line. Suppose this is called as the zero line. What is meant by the zero line? Yes, zero line is nothing but it is the graphical representation of. Yes. Yes, zero line is nothing but it is the graphical representation of
Basic size.
basic size. Now see, this is the zero line. We can call it the zero line. Now what that zero line is indicate? Zero line is indicate it is the exact basic size. Exact basic size. Okay, for example, what is the example we have taken here? For example, please try to understand the concept. Suppose 30, okay, 30 plus 2 minus 1. Okay. Now see what is the basic size is here. Basic size is equal to 30. Okay. Now see this zero line. That zero line, it is indicate the exact 30 mm. It is indicate the exact basic line. म्हणजे ह्या 30 ह्या लाईन वर 30 कुठे असायला पाहिजे? ह्या लाईन वर मला 30 दाखवायचे असेल तर फिअर I have to show that 30 mm because that 30 mm is the basic size, and you have to remember this sentence is very important. Okay, the zero line it is nothing but it is the graphical representation of the basic line, and the zero line it will show the exact basic size. Zero line it is showing the exact basic line. आता मला सांगा ह्या zero line वर मला 30 दाखवायचं कुठे मी दाखवेल? येस
होतं पण
इथं क्लिअर दाखवू शकतो का?
नो सर लाईनवर
line. Okay. See, exact. This line is indicate the exact basic line. See, this is the 30. This is the 30. Here only we can show the 30. And right now, you have to remember the upper side, it will be the positive side of your zero line. And here, this below side, it will represent the negative side. Okay. And here, it is called as the zero line. And you have to remember that zero line, it will indicate the
बेसिक साईज
basic size. That zero line, it will indicate the exact basic size. Okay. आता मला सांगा if we have to find out again what is meant by the deviation. What is meant by the deviation? Deviation is nothing but it is the actual minus basic size. Okay, actual minus basic size. What is the actual? Suppose we are taking 31 is the actual size. Okay, for example, 31 it is the actual. Then what is the deviation? Please tell me here. What is the actual? It is the 31 mm, and what is the basic? It is the 30. Then yes,
1
it is the 1 mm. But whether that 1 mm is positive or negative,
पॉझिटिव्ह
here we have to show. Here we have to show
अप्पर साईड
upper side. Means suppose it will be like this here. It will be here. Means this म्हणजे ह्या ठिकाणी आपण काय दर्शवू शकतो की तुमची साईज कितीने डेव्हिएट झाली कितीने डेव्हिएट झाली ऍक्च्युअल साईज पासून सॉरी बेसिक साईज पासून 1 mm दॅट मच डेव्हिएशन म्हणजे तुमची बेसिक साईज किती आहे आपली व्हॉट इज द बेसिक साईज इट इज द 13 mm ओके आणि 13 mm पासून किती वरती गेली किती डेव्हिएट झाली 1 mm इट इज द 30 okay if it is 32 like this it is the 32 it is the 33 okay if it is like this -1 is there if there is a -1 then how we have to show
बॉटम साईड
bottom side okay it will like this is called as the deviation this is called as the upper deviation and this is called as the lower deviation okay upper deviation and lower deviation एक concept आला का लक्षात तुमच्या yes
येस सर
म्हणजे त्या 30 पासून किती डेव्हिएट झाले आणि 30 पासून खाली किती डेव्हिएट झाले okay if it is upper it is positive if it is lower from that zero line then it is the negative okay. So I will write down here definition upper deviation okay again that deviation having the two types upper deviation and lower deviation okay upper deviation and what is the definition for that upper deviation we just see here it is the algebraic difference between maximum limit size and the basic size So, maximum limit size minus basic size and what is the definition for that lower limit yes please lower deviation yes what will be the definition yes
इट इज डिफरन्स बिटवीन मिनिमम लिमिट साईज अँड बेसिक साईज
minimum limit size and basic size okay now see now we will take the example okay upper limit is nothing but it is the maximum limit size and it is the difference between maximum limit size and the basic size okay for example we will take here 30 plus 5 minus 2 Okay, actually that limits it will be in pointer, but for your understanding I will take directly a digit. Okay, then first upon find out the maximum limit size. Maximum limit size means what? It is the upper limit. What is the upper limit? What is the upper limit for this? Yes,
30 plus 5.
30 plus 5 is equal to the 35. Then what is the lower limit? What is the lower limit? 30 minus 2, it is the 28. Okay, okay, yes or no?
Yes.
Then we have to find out the deviations. Deviation. Okay, then what is the upper deviation? Upper deviation is equal to maximum limit size. What is the maximum limit size here?
35.
Maximum limit size means upper limit, and minimum limit size means it is the lower limit. Then upper, we can I write here upper limit minus basic size. Upper limit minus basic size. Please tell me, what is this upper limit? It is the 35 minus what is the basic size? It is the 30. Then tell me, what is the deviation?
5.
Okay, 5 is the deviation. It is called as the upper deviation. म्हणजे जास्तीत जास्त आपण त्या 30 पासून किती लांब जाऊ शकतो, किती डेव्हिएट करू शकतो? 5. Okay, then how to find out the lower deviation? Yes, lower limit minus basic size. What is the lower limit?
28.
28.
20s minus basic size. What is the basic size is here?
30.
Then tell me the lower deviation.
Minus.
-4.
Minus
2.
this is called as the lower deviation. म्हणजे बेसिक साइज पासून मायनसला आपण किती जाऊ शकतो तर 2. दिस इज द ऍक्च्युअल डेव्हिएशन काढायचं असेल तर डेव्हिएशन आफ्टर द प्रोडक्शन किती डेव्हिएट झाला तर काय असेल? यस यस, फक्त मला डेव्हिएशन काढायचं आहे. हाऊ टू फाइंड आउट दॅट डेव्हिएशन? व्हॉट इज द फॉर्म्युला फॉर द डेव्हिएशन?
Actual minus basic.
Actual size minus basic size. Suppose here actual size it will become the actual size आपली कशी येणार इथं? What is the limit? Maximum limit it is the 35. Okay, and minimum it is the 28. म्हणजे ह्या मिडल ला कुठेतरी येणार ना. For example, we will take here how many? Please tell me. 32. Okay, 32 all up after the production size. Then what is the deviation for that? Actual size is the 32 minus it is the 30. What is the deviation?
2.
2 mm deviation. Okay, so understood? Yes.
Yes, sir.
Okay.
Yes, sir.
Okay, so any doubt, any problem is there up to this? Okay, we have seen limit. What is meant by the limit? Limit is nothing but it is the two extreme permissible sizes. Again, that limit having two types. First is the upper limit, second is the lower limit. Okay, what is meant by the upper limit? Upper limit is nothing but it is the maximum permissible size. Simple, maximum permissible size. And what is the lower limit? Lower limit is nothing but it is the minimum permissible. What is meant by the tolerance? Yes, what is meant by the tolerance? Yes, what is meant by the tolerance?
Difference between upper limit and lower limit.
The difference between upper limit and lower limit, it is called as the tolerance. Okay, okay, then tell me what is meant by the nominal size?
Size in drawing only.
Remaining student.
Size of part in drawing.
Okay, the size of part in the drawing itself only. What is meant by the basic size?
Size of part after giving tolerance.
Okay, after giving the tolerance, it is called as the basic size. What is meant by the actual size?
After production.
Okay, after production, Okay, after the production, and we have measured the size of that component. What is the size after the production? It will be the actual size. Okay, then what is meant by the deviation?
Difference between actual size and basic size.
Okay, the deviation is nothing but it is the difference between actual size and basic size. Okay, what is meant by the zero line? What is meant?
Graphical representation of basic size.
It is the graphical representation of basic size.
Basic size.
And again, that zero line, it will indicate the exact
Exact basic size.
basic size. Upper side of that zero line. Okay, the upper side of that zero line, it will indicate the upper deviation. Then it will be the positive side, and below it will be showing the negative side. Okay. Okay. Then again, deviation having two types. Okay, first is the
Upper deviation.
okay upper deviation, and second is the
Lower deviation.
lower deviation. Then tell me what is meant by the remaining student. What is meant by the upper deviation? What is meant by the upper deviation?
Upper limit minus basic size.
Okay, upper limit minus basic size, and lower deviation is nothing but it is the lower deviation minus basic size. Okay. So up till now, any doubt, any problem is there? Yes. Yes. Can I take next point? Yes.
Yes, sir.
Okay. So again, very simple point is remaining here. Allowance. Okay. Just write down here. Allowance. Allowance. What is the meaning of that allowance? Allowance. Okay, the allowance is nothing but okay. Allowance is nothing but it is the difference between it is the difference between two mating parts. It is the difference between two mating parts. Okay. Difference between the two mating parts. Okay. For example, for example, if suppose we are having one hole is here. Suppose we are having one hole is here. Suppose this is the one hole. You have to imagine. Okay, suppose this is the one hole, and the diameter of that hole, it will be the diameter of that hole, it will be, for example, it will be the 30. It will be the okay. It is called as the hole. It is the hole. Okay. Now we'll draw here one shaft. 1 minute. Suppose this is the shaft. Okay. Suppose this is the shaft. Okay, so this is the shaft, and the diameter of that shaft, it will be, for example, the diameter of that shaft, it will be the, suppose 25. The diameter of that shaft, it will be the 25. Then what is the allowance here? Yes, anybody, any idea? Allowance. What is the allowance? The allowance is nothing but it is the difference between two mating parts. Okay, now see, this is the shaft. This is the shaft and this is the hole. Okay, now we have inserted this shaft into this hole. Okay, suppose we have inserted this shaft into this hole. Then how to calculate the allowance? Allowance is nothing but it is the difference between two mating part. What are that two mating part? Hole is our one mating part, and that shaft is another second mating part. We have assembled that. Okay, suppose we have inserted that shaft into that hole. Okay, then how to calculate the allowance? Allowance is nothing but it is the difference between two mating parts. Okay, means what is the sizes of that two part? It is the 30 minus 25. Okay, then what is the allowance? It will be the 5 allowance. Means what? Suppose, for example, you just, it is visible to all. Yes, it is visible to
Yes.
all. Okay, now see, it is, you have to assume it is the hole. Okay, it is the hole, and suppose this is the shaft. Okay, so this is the shaft. We have inserted that shaft into this hole. Okay, then what is the difference between that two mating part? म्हणजे दोन जर पार्ट एकमेकांमध्ये आपण इन्सर्ट केले तर ह्याच्यामध्ये काहीतरी डिफरन्स आहे का नाही? Okay, that difference is called as allowance. It is understood? Yes.
Yes.
Okay, you have to remember the allowance is nothing but it is the difference between two mating parts. Okay, understood? It is understood all. Yes.
Yes, sir.
So last part is types of tolerance. Last part we will take here and then conclude the lecture. Types of tolerances. Types of tolerances. Just a minute. Okay, the types of tolerance. Types of tolerances. Okay. Then before going to that, first of all we should know what is meant by the tolerance. Yes, please tell me. What is meant by the tolerance?
Difference between upper limit and lower limit.
Yes, remaining student, please tell me what is meant by the tolerance. What is meant by the tolerance?
The difference between upper limit minus lower limit.
The tolerance is nothing but it is the difference between upper limit minus lower limit. It is called as the tolerances. Okay, it is called as the tolerances. Okay. Then that tolerance it having the two types. Okay, that tolerance it having the two types. Okay, the first is it is called as the unilateral tolerance. Okay, the first type of tolerance is the unilateral tolerance. Unilateral tolerance. Okay, and the second type of that tolerance, it will be the bilateral tolerance. Bilateral tolerances. Okay. Okay, these are the types of tolerance. What? The first is tolerance. Tolerance is nothing but it is the algebraic difference between upper limit and lower limit. It is called as the tolerance. Again, that tolerances are classified. The tolerance are classified into the two types. The first type is unilateral tolerance, and the second is the bilateral tolerance. Okay. Then, what is meant by the uni and what is meant by the bi? Please tell me. Okay.
Uni
Now,
means only one and bi
okay.
means two.
Okay, good. Okay, just you have to remember the definition of that unilateral tolerance and the bilateral tolerance from that two words only. Uni means one, and bi means two. Means what? Okay, now see here that unilateral tolerance is nothing but, okay, the unilateral tolerance is nothing but when we are showing the dimension of the parts. Okay, when we are showing the dimension of the part only one side of basic size. Okay, when where or simple, you have to remember when we are varying the tolerances. Okay, when we are varying the tolerances of that part only one side of basic size. Okay, when we vary the sizes, or we can say the tolerance, when we are vary the tolerance only one side, only one side of basic size, only one side of basic size, then it is called as the unilateral tolerance. Okay, then you have to remember, then what is meant by the bilateral? Yes, you have to prepare the definition according to that unilateral tolerance. Yes, when we vary the tolerance when we vary the tolerance, yes, on both side of basic size, on the both side of basic size, it is called as the bilateral tolerance. Okay, so understood? Okay, just have to remember this definition. Unilateral tolerance means we are showing the dimension to that part only one side of the basic size, only one side of the basic side, and bilateral means on the both the side of basic size, on the both the side of basic size. Okay. Okay, just I will take example here. Okay, now for example, okay, 25 plus just one minute. $25 plus 1, okay, and plus 0. Then please tell me what is the basic sizes here? What is the basic size?
25.
25 is the basic size. Then please tell me upper limit. What is the upper limit?
26.
Yes, 26. Then what is the lower limit is here?
25.
आता मला सांगा, ह्याच्यामध्ये we are showing that limits, or we can say that when we are showing the dimension to that part only one side, of the basic size. What is the basic size? Basic size is the 25. जर आपण टॉलरन्सेस हे जे टॉलरन्स जे आहेत वरचे हे जे काय टॉलरन्स आहे तो टॉलरन्स आपण जर एकाच साईडला बेसिक साईज दाखवत असेल एकाच साईडला म्हणजे एकतर प्लसला किंवा एकतर मायनस मायनसला okay, if such type of the tolerances are there, if such type of the sizes were showing, it is called as the unilateral or bilateral.
Unilateral.
It is called as the unilateral. It is called as the unilateral. Why it is called as unilateral? Because these tolerances, or we can say the sizes, were showing on one side only, one side to the basic size. म्हणजे एक तर प्लस प्लसला दाखवते किंवा मायनस मायनसला दाखवते. फॉर एक्झाम्पल the next example is suppose 25 minus 1 minus 2. Whether it is unilateral or bilateral?
Unilateral.
Why it is called as the unilateral? Yes. Why it is the unilateral? Why it is the unilateral?
Because it is on negative side only.
Okay, we are showing the dimensions of tolerance in negative side only, and here we are showing the dimension of the tolerance in positive side only. Okay, म्हणजे एकाच कुठल्या तर साइडला आपण दाखवत असेल एक तर पॉझिटिव्हला दाखवत असेल तर एक तर निगेटिव्हला दाखवत असेल that time we can call it is called as the unilateral tolerance. Unilateral tolerance. Okay, understood? Yes.
Yes.
Then please tell me next example I'm going to write down here. Next example. Okay. 25. Okay. 25 plus 0.00. Okay. And plus 0.02. Then please tell me what is the basic sizes here?
25.
Basic size is the 25 mm. Then please tell me the upper limit. Okay.
25.02.
25.02. Then what is the lower limit?
25.
25 is the whether this is bilateral tolerances or it is the unilateral tolerances.
Unilateral.
Why it is the unilateral? Why it is the unilateral? Because we are showing the tolerance in only one side, in positive side only positive side, so that it is called as the unilateral tolerances. Then please tell me the next example is okay. Then tell me right now. Suppose I'm going to take here the next example. It will be 25. Okay, minus. Okay, minus 0.01 minus 0.02. Then tell me what is the basic sizes here?
25.
25 is the basic size. Then tell me the upper limit. What is the upper limit?
25.02.
Yes. 20 upper limit.
24.99.
24.98.
is the upper limit, maximum, and minimum किती असणार आहे? Lower limit is equal to 24.98. 98 is smaller or that 99 is smaller?
98.
Okay, so that it is called as upper limit, it is the lower limit. Okay, then tell me which system is there? It is unilateral tolerance system or it is bilateral tolerance system?
Unilateral.
It is unilateral. Why it is called as unilateral? Because here the dimension they have showing on only one side of that basic size, means only negative side they have showing, only negative side. Here they are showing the only positive side. Okay, if such type of the tolerances are there, then it is called as the unilateral tolerances. Okay, then now then okay, then how to show that tolerances on graphical representation. Suppose this is the basic size, or we can call it is the zero line. Na? It is the zero line. Okay, zero line. Then that zero line, it will indicate the basic size. It is the 20 mm. Okay, for this example we are going to write down here. This is the tolerance zone. Okay, suppose this is the upper limit and this is the lower limit, like this. Okay, because in this side it will be the positive, and in this side it is the negative. Okay, so understood? Yes. Okay, now take next. What is the next? Bilateral tolerances. Okay, then tell me what is meant by the bilateral tolerance. What is meant by the bilateral tolerance?
Tolerance is shown on both side of basic size.
When we are showing the tolerance, or when we are showing the size of that part on the both the side of basic size, on the both the side of basic size means on the plus side also we are showing, and on the negative side also we are showing. Okay, if such type of the arrangement is there, positive and negative, then we can call it is the bilateral tolerances. Then we can call it is the bilateral tolerances. For example, suppose 45, okay, 45 plus 0.03 and minus it will be the 0.02. Then here tell me the basic size. What is the basic size?
45.
45. Then tell me the upper limit is the 45 plus
45.03.
0.03 is equal to, calculate and tell me, and lower limit is equal to 45 minus 0.02. Then tell me what is the upper limit, what is the upper limit, it is the 45.03 mm, and the lower limit will be, it will be the 44 minus 98 mm. Okay, okay, so it is called as the bilateral tolerances. Why it is called as the bilateral tolerances? Because we are showing the tolerances of sizes on the both the side of basic size, on the upper side and lower side also. Okay, so understood?
Yes, sir.
Okay, so you have to remember this 2 points also, unilateral and the bilateral tolerances. Okay, so any doubt, any problem? Yes. Yes, please.
No, sir.
Okay, so once again I will revise which point we have covered in that today's lecture. Okay, Please tell me which point we have covered in that today's lecture. Please fast. Okay, first up on we have seen the sizes. Okay, it having the three sizes. First is the
Nominal,
nominal sizes, then basic size.
basic,
Okay, the basic size. Then third is the
actual,
actual size. Then next point, which point we have taken? We have seen
deviation,
limit. Okay, then limit. Again, limit having two types. What are that types?
upper limit and lower limit.
Upper limit and the lower limit. Okay, upper limit means what? It is the maximum permissible size, maximum extreme permissible size, and it is the minimum permissible size. Okay, then the next point, tolerance. Okay, tolerance. What is meant by the tolerance? It is the difference between upper limit and the lower limit. It is called as a tolerance. Okay, upper limit minus lower limit. Then what are the different types of the tolerance? There are two types of the tolerance. What are the
Unilateral and bilateral.
okay, unilateral and bilateral. Unilateral means only one side of basic size we are showing the tolerance. It is called as unilateral, and when we are showing the tolerance on the both the side, means here only plus or only negative. Here we have to show the plus side and negative side also from the basic size. Then we have seen next point is the deviation. Okay, deviation. Then what is meant by the deviation? It is the algebraic difference between actual size and basic size. Okay, then again the deviation having two types. What are the deviations?
Upper deviation and lower deviation.
Upper deviation and the lower deviation. Okay, first is the upper deviation and second is the lower deviation. Then what is meant by the upper deviation? Upper deviation nothing but it is the upper limit
Upper limit minus basic size.
minus basic size. And then what is meant by the lower limit? Lower deviation. It is the lower limit minus basic size. It is correct?
Yes, sir.
Okay, then we have seen allowance. What is meant by the allowance? What is meant by
Difference between two mating parts.
it is the difference between two mating parts. Okay, then what is meant by the zero line?
Graphical representation of basic size.
And it is showing the zero line. It is showing the exact
Basic size.
basic size. Okay, that much point we have covered in this today's lecture. So please tell me, anybody having any doubt, any problem with that? Yes. Remaining students, anybody having any doubt, any problem? ह्यातलं काही समजलं नाही, please tell me. Yes, बुरुंगळे.
Yes, sir.
Whether you have understood that all the points?
Yes, sir.
Can you tell me what is meant by the actual size? Yes. What is meant by the actual size? Mansi Chavan, can you tell me what is meant by the actual size? Priyanka Jankar,
Yes, sir.
can you tell me what is meant by the basic size?
Size of part after giving tolerance.
Then what is meant by the actual size?
Size of part after production.
Then, okay, good. Then remaining anybody? Okay, now thank you. We will stop here.